Hello my dear students. Today we are going to start with the fifth chapter of the chemistry of class 10th, that is periodic classification of elements. Here there are two new terms, periodic and classification. What do we mean by periodic? Periodic means the tendency to repeat after a fixed interval of time. Whenever anything repeats after a fixed interval of time, then we call it as period. And as it repeats after, here it's periodic, which means tendency to repeat after a fixed interval of time. And the other is classification of elements. What do we mean by classification of elements? Classification means grouping of elements on the basis of similarities and dissimilarities. So here in this chapter we'll study about the classification of element and repetition of the properties after a fixed interval of time. So first question here which comes to our mind is why there is a need to classify the elements? So the elements which are known to us till today are 118. So 118 elements, it's very difficult to study each and every element individually, because it will take more time and it will not be easy to learn the properties of each and every element differently. So we divide these elements into different groups on the basis of similarities and dissimilarity, so that if we study the property of one element, we'll come to know the properties of other elements also. So it will save our time and it will make our learning easy. There were many attempts which were made by different scientists, and out of those early attempts at classification of elements, the first attempt was made by Antoine Lavoisier, and he tried to classify all the elements known at that time. I believe 30 elements were there at that time, into metals and non-metal. But the main drawback of this classification was that there were some elements which could neither be classified as metal or as a non-metal, which we later call them as metalloid, जिनको हमने बाद में metalloid बोला. He was not able to classify those elements. Therefore, this system of classification was rejected. After Lavoisier, Döbereiner made the second attempt to classify the elements. Döbereiner, he classified the elements into a group of 3 on the basis of the increasing atomic mass. And in the group of 3, the mass of the middle element was the average of the atomic mass of the first element and the third element. For example, in case of the alkali metal triad, the mass of lithium is 6.9, which is approximately 7, and mass of potassium is 39, and if we take the average of these two, the average comes out to be 23, which is the mass of sodium. So what is Döbereiner triad? According to Döbereiner triad, when the elements are arranged in a group of 3 on the basis of increasing atomic mass, then the atomic mass of the average element is the average of the atomic mass of first and the third element. Like this triad, 2 more triads were given by Döbereiner. One other is alkaline earth metal triad, which consists of calcium, strontium and barium. Then halogen triad, which consists of chlorine, bromine and iodine. Why we call it as alkali metal triad? Because the metal of this group, they react with water to form strong alkalis. Why this group metals are called alkaline earth metal triad? Because their oxide or hydroxide, they are alkaline in nature, and their oxides are found in earth crust. So they are called alkaline earth metal triad. And why the third one are called halogens? Halogen is made up of 2 words, halo and gen. Halo means salt and gen means forming. As these non-metal, they form salts, therefore they are called halogen triad. But Döbereiner triads was also rejected. Why? Because he could make only 3 triads. All the elements known at that time, he couldn't place them in the triad, so his classification was also rejected. After Döbereiner, the next attempt was made by Newland. So Newland attempt was named as Newland law of octave. Newland arranged the elements on the basis of their increasing atomic mass. And when he arranged the elements on the basis of increasing atomic mass, the properties of the first element was similar to that of every 8th element. And this was similar to that of the musical note. Like in musical note, sa, re, ga, ma, pa, dha, ni, sa. Sa repeat itself after at 8th place. In the same way, when elements are arranged on the basis of increasing atomic mass, the properties of the every first element is similar to that of the 8th element. Therefore, his law was named as His law was named as law of octave. So what is Newland law of octave? According to Newland law of octave, if elements are arranged in the order of increasing atomic masses, every eighth element had similar properties to that of the first element, like the first note and eighth note of musical scale. Now, this law was also rejected. Why? Because of some limitation. So what were the limitations or drawbacks of the Newland law of octave? The first limitation was that it was applicable only up to calcium, that is only up to 20th element. However, at that time 56 elements were known to Newland, and out of 56, Newland could arrange only 20 elements as on the basis of the increasing atomic mass. Then second drawback was Newland new elements which were discovered didn't fit in this table. That is the discovery of noble gases. When the noble gases were discovered, Newland could not fit those noble gases in his periodic table. The third drawback was he adjusted two elements in the same slot, like cobalt and nickel. They were placed at the same slot. So this was another limitation. And some unlike elements, they were kept along in the same column, like cobalt and nickel, which were placed along with fluorine, chlorine and bromine. Although their properties were not similar to that of fluorine, chlorine and bromine. So this law was also rejected. After Newland, the next attempt for classification was made by Mendeleev. And Mendeleev's attempt to classify the element was the most accepted at that time. According to Mendeleev's classification of elements, when elements are arranged on the basis of increasing atomic mass, the elements with similar properties, they repeat themselves after a fixed interval of time. So on this observation only, which observation? That when elements are arranged on the basis of increasing atomic mass, the elements with similar properties, they repeat themselves after a fixed interval of time. Mendeleev gave its periodic law, which was known as Mendeleev periodic law. So what is Mendeleev periodic law? According to Mendeleev periodic law, the properties of the element are the periodic function of their atomic masses. The properties of the element are the periodic function of their atomic masses. What does it mean? It means that when elements are arranged on the basis of increasing atomic mass, elements with similar properties, they repeat themselves after a fixed interval of time. Now, in his periodic table, Mendeleev classified the elements into 8 groups and 7 periods. He classified the elements into groups and periods. What are groups? The vertical column in the periodic table are known as groups, and the horizontal rows in the periodic table are known as periods. There were total 8 groups and 7 periods. Out of those 8 groups, 7 were divided into 2 subgroups, that is A and B, but last, that is 8th, was divided into 3 subgroups. And there were total 7 periods, horizontal. For the chemical properties, Mendeleev considered the formulae of oxide and hydrides of the element. That is, he considered the reaction of the hydrogen and oxygen with the element. Now, question here is why Mendeleev took only hydrogen and oxygen for the chemical properties? Because hydrogen and oxygen are the most abundant gases and are the gases which react almost with all type of the elements. Therefore, for the chemical properties, Mendeleev considered the reaction of the hydrogen and oxygen with the elements, that is the formula of hydride and oxide of the element. Now, when he was arranging the elements into groups and periods, actually what Mendeleev did? Mendeleev, he prepared some placards where he write the symbol of the element like X. Then he write the formula of the oxide and the hydrides of the element and the atomic mass of the element. And he was arranging them on the basis of increasing atomic mass. When he was arranging on the basis of increasing atomic mass, he gave more preference to the chemical properties. Where he was, जहाँ उसको लगा भी यार इस ग्रुप में कुछ एलिमेंट ऐसे जिनकी प्रॉपर्टीज उन ग्रुप के उन एलिमेंट से नहीं मिल रही, तो what Mendeleev did? He left some gap in his periodic table. He left some gaps in his periodic table and he predicted some elements. उसने कहा यार ये मैं गैप इसलिए छोड़ रहा हूँ, in future some new elements will be discovered. कुछ एलिमेंट नए डिस्कवर होंगे. And he predicted the properties of those elements also. उन्होंने उसकी प्रॉपर्टीज भी प्रेडिक्ट कर दी. Later on, when those elements were discovered, the properties which were predicted by the Mendeleev were same as those elements at that time had. And Mendeleev named those elements also. जो भी the element for which Mendeleev left some gap, he also gave the name to those elements also by using the prefix ikka, which is a Sanskrit word. Prefix ikka. जैसे हम काउंटिंग में करते हैं 31, 30 के बाद एक 31, 40 के बाद एक 41, 50 के बाद एक 51. इन द सेम वे Mendeleev ने क्या किया, जो एलिमेंट डिस्कवर होना था उससे पहले वाले एलिमेंट के साथ क्या लगाया, इक्का. लाइक फॉर स्कैंडियम he wrote ikka boron. For gallium he gave the name ikka aluminium, and for germanium he gave the name ikka silicon. And when these elements were discovered later on, the properties which were predicted by the Mendeleev were same as of these elements. So this was the big achievement of the Mendeleev, and this was why his model his classification was most accepted at that time. Let's now recall what are the characteristics of the Mendeleev periodic table. What we have discussed now, that all can be summarized into the characteristics of Mendeleev periodic table. So first characteristic is that Mendeleev periodic table is based upon increasing atomic mass. Second is that 63 elements were discovered at that time, and Mendeleev could place all the elements in his periodic table. He placed all the elements into 8 groups and 7 periods, as I have told you. Further, these groups were divided into subgroups. First 7 groups were divided into 2 subgroups, and the last group, the elements were arranged in 3 rows. Groups 1 to 7 were subdivided into 2 subgroups, A and B, and 8th group divided into 3 subgroups. Elements with similar properties were kept in the same group. Those elements which are in the same group, they were having the same properties. So these are the characteristics of the Mendeleev periodic table. And what were the merits of Mendeleev periodic table, due to which the Mendeleev periodic table become very popular at that time? Those merits were, elements with similar property were placed in same group. So if we study the property of one element, the properties of other elements can be predicted very easily. Second, it helps in the discovery of many new elements, as Mendeleev left some gaps in his periodic table depending on the chemical properties and increasing atomic mass, and he predicted some new element, and later on those elements were discovered also. He corrected the mass of some elements like beryllium. When Mendeleev was classifying the elements into his periodic table, at that time the atomic mass of beryllium was supposed to be 13.9, I think, and then Mendeleev corrected it to 9.1, and the valency was considered to be 3, and later on he corrected it to 2. So Mendeleev corrected the atomic mass of certain elements also, like beryllium. So this was his great achievement. Then, in spite of all these merits and becoming so popular at that time, his model was also rejected. Why? Because of certain limitations or drawback. The first limitation was that position of hydrogen was not correctly defined. As we all are aware that some of the properties of hydrogen resembles to that of alkali metal and some to that of halogens. So where to place? Mendeleev could not explain it. Then position of isotopes. As we all know that isotopes are the atoms of same element having same atomic number but different atomic masses. As isotopes have different atomic mass, so according to Mendeleev, as Mendeleev periodic table was based upon increasing atomic mass, so position of the isotope should be different, but they were placed at same position. Why? Mendeleev couldn't explain it. Then elements with similar properties are placed in different groups, like copper and copper and mercury. They both have same properties, but they were placed in different groups. Then certain elements having different properties, they were placed in same group. For example, lithium, sodium and potassium. They were having the same properties, but they were placed with copper, silver and gold. The properties of copper, silver and gold were entirely different from that of lithium, sodium and potassium. Then Mendeleev was unable to explain the cause of periodicity. Why elements with similar property repeat after a fixed interval of time? What is periodicity? I told you earlier also. Periodicity means repetition of elements with similar properties after a fixed interval of time. Why this was happening? Mendeleev couldn't explain it. The next drawback is that the order of atomic masses was not obeyed. Order was not obeyed means the element with higher atomic mass was placed before the elements with lower atomic mass. For example, this cobalt with atomic mass 58.9 was placed before nickel with atomic mass 58.7. However, the table was based upon increasing atomic mass. So, the elements with lower atomic mass should have been written first, and elements with higher atomic mass should have been written after it. But somewhere he placed elements with the higher atomic mass before the element with the lower. This was also his drawback. One more drawback was that somewhere the difference in the atomic masses were more and somewhere the difference in the atomic masses was less. So he was not able to predict how many new elements will be discovered, because difference in the atomic masses was not increasing in a regular manner, especially in case of higher elements. So because of these all drawbacks, Mendeleev's model was also rejected. After Mendeleev, the attempt to classify the element was made by Moseley. Moseley, he did many experiments in Henry Moseley. He did many experiments in 1931, and after his experiment, what he concluded that the periodicity of the element is not because of atomic mass. The properties of the element, it doesn't depend upon the atomic mass, but it depends upon the atomic number. He said that when the elements are arranged on the basis of increasing atomic number, then the elements with similar properties they repeat themselves after a fixed interval of time. So from here he gave his law, he changed the law and he gave his law which was known as Moseley's periodic law or modern periodic law. What is modern periodic law? According to modern periodic law, physical and chemical properties of the elements are the periodic function of their atomic number. And he gave the cause of periodicity also, which was the drawback of the Mendeleev periodicity. Mendeleev could not give the cause of periodicity, but Moseley gave the law cause of periodicity. Repetition of similar chemical properties after a fixed interval of time is because of the repetition of the similar electronic configuration. Repetition of similar chemical property after fixed interval of time is because of the repetition of similar electronic outer electronic configuration. For example, in case of group 1, that is alkali group, lithium, sodium, potassium, rubidium, cesium and francium, all the elements they have same chemical property. Why? Because they all have same outer electronic configuration, that is they all have one valence electron in their outermost shell. As they have one valence electron, that is same valence electron in the outermost shell, so they have same chemical property. So cause of periodicity is the repetition of the similar outer electronic configuration after a fixed interval of time. Let's move on to the characteristics of modern periodic table. So it's simple. Modern periodic table is based upon the atomic number, that is properties of the elements are the periodic function of their atomic number, and this table consists of 7 horizontal rows which are known as periods and 18 vertical columns which are known as groups. Now what are periods? As I told you, the horizontal rows are called period, and there are only 7 periods. Out of those 7, first period is called the shortest period, which consists of only 2 elements. Second and third periods are called short period, which contains 8 elements each. Fourth and fifth period are called long period, as they contain 18 elements each. And sixth and seventh period are the longest and contain 32 elements each. And this number 2, 8, 8, 18, 18 and 32, they are called magic number. They are called magic number. Now groups. Elements in the same group, they have same number of valence electrons. What are groups? Vertical columns are called groups. How many groups are there? 18 groups are there. And in each group, the number of valence electrons are always same. All the elements of the same group, they have same number of valence electrons, due to which they have same properties. Number of shell increases down the group. As we do move down the group, the number of shells keep on increasing. The number of valence electrons remains same, but the number of shells will keep on increasing. Element of group 1 are called alkali metals because their oxides are soluble in water and form strong alkalis. Then elements of group 2 and 2 are called alkaline earth metal because their oxides are found in the earth and are soluble in water. Elements of group 16 are called chalcogens because the elements of this group, they generally forms the ores. Most of the ores of the copper are made up of elements of this group. Elements of group 17 are called halogens. Why they are called halogens? As they form salt. Halo means salt and gen means forming or producing. So as they produce salt, So they are called halogens. The elements of group 18 are called noble gases or inert gases. They are called noble inert gases because they are highly inert gases. They do not react with any other element at normal conditions. So they are called noble gases or inert gases. Now let's discuss the merits of the modern periodic table, due to which modern periodic table has become so popular that till now we are using this table only. What are the merits? It is based upon the atomic number, which is a more fundamental property of element than atomic mass. Actually, this was the main drawback due to which all the other classifications were getting rejected one after another, because they all were trying to classify the elements on the basis of atomic mass, which was not the periodic property. Actually, the periodic property is atomic number. So, and Moseley classified the elements on the basis of atomic number, and he gets success also. Position of isotope, which was the drawback of Mendeleev periodic table, because isotopes are the atoms of the same element which have same atomic number but different atomic mass. So as they have different atomic mass, so according to Mendeleev they should have been placed in different position, but they were placed at same position. Why? Because they have same atomic number, and modern periodic table is based upon same atomic number, so they were placed at the same position in the periodic table. It makes the study of elements simpler, because we were able to group the elements, all those elements which have same properties, into the same group. So if we study the property of one element, we can easily study the property of all the other elements of the same group. The position of those elements which was not justified on the basis of atomic mass is justified on the basis of atomic number. Like he placed some elements with higher atomic mass before the elements with lower atomic mass, but as this table was based upon atomic number, so there was no such drawback. Lanthanides and actinides are placed separately because their properties did not match elements of other groups. Although lanthanides and actinides, they are the part of period 6 and 7, but he placed them separately at the bottom of the periodic table because their properties were altogether different from the rest of the elements. The table is easy to remember and reproduce, as it is based upon atomic number on the basis of the electronic configuration, so it is very easy to remember and reproduce. Still there are certain demerits, and what are those demerits? Position of hydrogen. Still position of hydrogen is not justified. Although Moseley placed the hydrogen at the top position of the periodic table because of the atomic number, as atomic number is 1, so it is placed at the first position in the periodic table. But still, the properties of hydrogen are same as that of alkali matter, and some of the properties are same as that of halogen. So still its position is not justified, and lanthanide and actinides are kept out of the main body of the table. This is again the drawback. So here we end with the attempts to classify the elements. In the next lecture, in the next video, we will study about the position of elements in the periodic table and the trends in the periodic table. Hope you have understood this, and I will also keep on providing you the notes of this video lecture along with the video.